So I'm gonna show you very quickly on how to get from a scanned infrastructure to code that you actually would like to have in your Git repository. So the scanning has happened already in this account. We onboarded a couple of connectors to AWS and Azure, scanned the code, identified 5,000 resources, and already give suggestions on what resources fit very well together. We see a virtual network, we see a Azure virtual machine, and the VPC. And because the VPC has a few more resources, it's going to be interesting how they are getting combined. I'm gonna choose this one as the codification for the codification process. It gives me a lot of good information, 13 resources overall. It's going to be a VPC, multiple subnets, and some gateway, internet gateway, and routing tables. That looks good. I'm going to add them. In the bottom left, I see that shopping cart has been populated. I can also add from all the resources that I see here more to my codification process, but I'm happy for now. I see if I do codification, I get 0.26% of more codification, and they're gonna start the process. So what I went a bit fast over, I can explain now, because while it is codifying the infrastructure, I tell you what other options you would have had. So instead of choosing the predefined resources that are coming in the package, and we already calculate them because they are most suitable, you could have also chosen one by one, singular choices, choosing by tagging, if you have good tagging convention or naming convention, and they are bundled via tags, so a whole application is following a specific tag. Or you could also say I'm searching for a specific resource type and codify multiple resources of the same type. That could be also another selection that you want to do, and choosing them one by one and adding them to your cart, and then codifying that. Codifying can be done then on Terraform or on OpenTofu, so both they are fully supported. And what we see in this codification process now is the first results. So it's gonna get populated one by one, the different files, the modules that we see. On the left side, it builds out the whole structure based on modules. So everything is very modular. We see here parameterized as well. So for the VPC, it's not having hard coded the values inside of it. It can be reused, standardized very easily this way. And each of the resource types is the same way, categorized in modules. And on the bottom, we see the so-called caller code, which then is calling these modules to build the whole structure, in this case of the VPC, with the subnets that are working together as one template. What else is there to mention? The real values. So the values that are populating and that we chose can be found in the TFVARS file under the environments, because I guess you might have dev environment, prod, staging environments. The same idea is here behind it. So this environment shows a specific implementation and has a region, different VPC blocks, CIDR blocks, as well as tagging and subnets inside of it. So you see it has quite some contacts, ports, open ports that are available for ingress and egress. And this can be found all in the TFVARS. Besides that, the documentation is interesting because here we summarize everything, and it's easy to read for people who don't want to go through the code, what has been built here. And the last point I want to point out is the import statement. Of course, we have resources in the cloud and we want to have them now documented inside of the code, and especially for creating the state file in the next step, that's going to be very useful because you're going to have the resources in the cloud, the code then sitting in your Git repository, and the state file that is representing exactly what has been deployed.
And to add to it, while we're generating code, we're also continuously checking it against the real infrastructure in the cloud. So we're running plans and inits in the background. This is not only some AI generated code that you're looking at, but we're going to take it through the process that you would otherwise when creating code from just infrastructure. And in that process, using that import statements, we also create the state file. And as this process of codification comes to end, all of that is being combined together, and 5 minutes later, you will end up with a state file, with a plan, hopefully with 0 diffs, which means you can simply take this code and start applying with it and managing the state, as Frank highlighted, monitoring that infrastructure from then on using all of the code and the state file created.
What I will do now is do a bit fast forward because this can take a couple of more minutes. And I have here something that was already built, a very similar or exactly the same resource, a VPC with multiple subnets and other resources inside of it. We see here the modules being built, and then it finished. And as Akshat mentioned, there has been Terraform init and Terraform plan been running and resulted in a 0 diffs. So meaning that it's exactly what we deployed in the cloud, the code is representing. That's a very good state. And this is what I would like to push to my Git repository, because this way it can be reused for the next deployment. And of course I have it documented. And yeah, I have the code handy, and it can be the source for other deployments.